So the other day, I was watching YouTube, and this Johann Sedgborn fella says, "Can a $50 Marshall lead 12 sound like a plexi?" Well, in his hands, it does. But I thought maybe I would try it in mine. And I went looking for them, and there's Bendy. And I completely forgot about it until I was looking for some stomp box parts and came across this Nightfire kit. And it says 14-watt guitar amp with Marshall tone stack for $28.50. So I ordered myself up one. It uses this Tada 2030 output chip that can't decide if it's 18 watts or 35 watts or whatever. So we'll pull up the data sheet. Output power at 8 ohms is 12 watts. So we're on our way. I welded me up a little chassis that was kind of taken from the lead 12 dimensions given off like still water or something. I drilled myself some holes in it, made me some standoffs, started doing some test fitting some more. Here's the gain knob we're going to add to it. And these two jacks came with the kit as input and output. Marshall likes these plastic jacks. I think it's because it keeps the signal ground off of chassis. The paints I used, this gray spray paint came from Dollar General, and I was going to use it just as primer. I said that I welded up that chassis, and grinder and paint makes me the welder I ain't, and so I figured most of it would wind up on the floor anyway. And it turns out to be reasonably good stuff. Dries real fast. This gold from Ace, gold plate, it says. There was one can next to it that was a little brighter because, as you can see, the gold plate is a little dull compared to the Marshall. The chassis is complete. I ordered me some what I thought were Marshall-y looking knobs, chrome center with a little skirt. But it turns out those match the Boss. So yeah, there's that. The way op-amp gain is calculated is RF over RI. So the feedback resistor divided by the input resistor. And as shipped, this Nightfire kit has a gain of 10. Conversely, the 12 at this intermediate stage, the gain is 1,000. So it's not very Marshall-y. In fact, it is quite Fender-y. It's nice and bright and chimey. If you wanted to build you like a champ or something out of this, that would probably work fine. Also would probably make a good bass practice amp as well. Comes with this TLO71, very common op amp, but with what we're about to do to it, that little chip is not happy, and it oscillates terribly at any gain setting. Experimentally, I have come to the conclusion that the TI LF412 chip is the best substitute. However, the TLO71 is 1 op amp on an 8-pin dip, and the TL chip is 2. So you can see that 2 and 3 are inverting and non-inverting, and that 1 is the output versus 6. So what you have to do, and I put like a separate socket in between the board and the chip, and I jumpered 1 to 6 to get the output, and then you can see that B plus comes in on 7, but here it's 8. So you have to short 7 to 8 as well. So 1 to 6, 7 to 8 to get that the LF chip to work. So the way feedback works, I said, is RF over RI. The way it came shipped was with a 100K fixed resistor and a 10K fixed resistor. Well, we're going to add a 1 mega ohm potentiometer. We're going to leave this 100K fixed in it. If in the event you bottom out that pot, you're not shorting the output to the input. And we're going to change the RI from 10K to 1K. So the math then becomes 1.1 meg divided by 1K is 1100 for gain. So that's plenty of gain. However, it's not very distorted. So the way that like Klon, this is a schematic for a Klon pedal, gets away with that is that they hang a pair of germanium diodes off of the output of this intermediate stage. after, however, this coupling capacitor. That's very, very important. It is after that coupling capacitor that these diodes go to ground. Germanium diodes that Declan is very, very famous for, or whatever, have a forward bias voltage of 0.3 volts. And our little amp, even with that other op amp in it, is only swinging like 100 or so, 120 or so peak. So that won't even turn those germanium diodes on. And without seriously redesigning the circuit, we're not going to get any more voltage out of that single stage op amp. So I did some digging, and I found these BAT60 diodes. And they are a bitch to work with. They're in this SOD 323 case. If you look here, pin to pin, this H dimension is 2 millimeters. That's like 100 thousandths. So yeah, they're a pain. But extremely low VF drop of 120 millivolts. So these are going to work just fine to clip our signal at the end of that output stage. So here's what it wound up looking like. This is a piece of perf board with just those diodes soldered to it, and you can see one's facing left and one's facing right. And this goes across the volume, the existing volume pot that shorts the output of the op amp after the coupling capacitor to ground. You can see we're done with it. That gain pot is added. You can see I have switched over to some shielded cable. You can see that little board is behind the volume pot there. And you can see that we got it all done. It's in kind of a metallic blue, which is also very 80s. And here's the back side of it. This grate is from an old Yamaha receiver I found on the side of the road. I doubt we're going to get that Tada chip that hot to need a vent, but we have one nonetheless. And here's the part where you wish that I was a better guitar player, because we're going to play you some stuff. The modifications we've made to this circuit turn the treble knob into like a secondary gain knob. That is to say, with it at 10, it's not hitting the clipping diodes at all. But with the treble at 0, it's clipping the most. And so with the gain at 3 and the treble at 9 o'clock, 3 o'clock and 9 o'clock, we're going to play you a little ditty. Okay, so we're going to take the gain and put it all the way to max and leave the treble at 9 o'clock and play you another riff. And for what we've all been waiting for, the gain at maximum, the treble secondary gain at minimum, and let's see if 28 bucks can build you a Marshall Lead 12.